Our 8th lecture video on rotational motion will cover gear trains and idler gears. A gear train is a series of gears that transfer rotational motion from one gear to another. An intermediate gear that does not drive a shaft to perform any work is called an idler gear. The addition of each idler gear reverses the direction of rotation of the final gear in the gear train. Idler gears are sometimes used to transmit rotation among distant shafts in situations where it would be impractical to simply make the distant gears larger to bring them together. In this manner, idler gears can reduce the size of the input-output gears while maintaining the spacing of the shafts. Larger gears occupy more space and also have more torque, so in cases where the larger torque is impractical, idler gears are used. An idler gear also does not affect the gear ratio between the input and output shafts. Only the number of teeth between the first and last gear in a gear train affects the gear ratio, as long as the teeth on all of the gears mesh. A single idler gear can be used to reverse the direction, and this is referred to as a reverse idler. Manual transmissions engage the reverse gear by inserting a reverse idler between two gears. So we know a few basics about gear trains and idler gears. Let's talk about figuring out the direction of rotation of gears in a gear train. When there is an odd number of shafts in the gear train, the first and last gears rotate in the same direction. In this picture, we have 3 gears on 3 separate shafts. The first one rotates clockwise, the second one rotates counterclockwise, and the third one rotates in the same direction as the first one, which is clockwise. However, when there is an even number of shafts in the gear train, the first and last gears rotate in opposite directions. In the second picture, there are 2 gears on 2 separate shafts. The first one rotates clockwise, and the second one rotates counterclockwise. Let's take a look at one quick example regarding direction of rotation. Gear A turns clockwise. Determine the motion of gear B. In this picture, the first gear rotates clockwise. The smaller gear, whose teeth mesh with the first one, rotates counterclockwise. It is on the same shaft as the larger gear below it, and the entire shaft rotates counterclockwise. The next gear, whose teeth mesh with the gear on the bottom, rotates clockwise. This gear's teeth mesh with the small gear, which rotates counterclockwise. It is on the same shaft as gear B, so gear B also rotates counterclockwise. Another way we could have solved this is that there are 4 shafts, which is an even number, so the first and last shafts, or gears in this case, rotate in opposite directions, so gear B rotates counterclockwise. This concludes our discussion on the basics of gear trains and idler gears.